Okay, now continuing on, before going on to the next set of public functions, I just want to make a note about these. Well, you saw clear, that's okay. This resize, how that works, and what this SetLength is about, which are internal. You needn't worry about them, but I'll just show you what the deal is with resize. Resize is an internal function that's used to alter the size of the buffer, the object's buffer, to a number of elements given. Now, it's using realloc. Realloc is one of those weirdo functions that really shouldn't be called the way that I'm calling it. It's a very multi-purpose function, and what it does is it changes the size of the buffer passed in and returns to you a new value for that buffer. If the number if the buffer passed in happens to be null, then it does an malloc. Okay, so realloc becomes malloc in that case. If the number of elements passed in is 0, and this is an allocated string, then it does it free. So then realloc becomes the free function. If an error occurs, it returns null and does nothing to this. That's why this assignment is incorrect. But really, I should be checking for a null return and hanging on to my last and only reference to my allocated memory. However, I'm not worrying about that because 2 gigs worth of, at least worth of address space, the only way I'm going to get a failure in allocation is if something went terribly wrong. And that is being checked for here, although it's not being handled. This, if interpreted as an int, this number is negative, then that's probably an error. That would mean that this is a huge number and realloc might actually fail. But no big deal. It's not a big loss. In the case where it fails, I might get a little memory leak, and that's fine. Now this is passed in number of elements. The size of the buffer includes a multiplication by the size of the character type. So therefore resize is taking the value is in characters, not bytes. And SetLength here is something that one calls internally to change the value of the length of the allocated buffer. That is, we're trying to change this to this. Now let's see. If new length specified is equal to len, now this len just returns the value of this member. I could use that directly, but I use it as a function for some reason. Then do nothing. If new length is positive, and this is a new length value, then resize to new length plus 1 for a null terminator, put a null terminator in, and now I could just set this value equal to this, but I'm taking a string length, and this here should really, it would read better like this, because here I'm setting it, and basically I'm asserting that the string length calculated from the actual string is equal to what we just specified it to be. Now, if that fails, I have a comment here. It might be that there might be an intervening null terminator somewhere, and therefore this string length calculation came out lower than it should have been, and that would indicate an error of some sort. Because this is internal, the error is an internal error. It has to be handled internally. It's not an error. It doesn't indicate a programmer error. Someone who's using this class, it indicates an error in the class. Okay, so that's all for that. Now we've seen these. We can append, we can assign, and constructors and so on. And if everything's working okay, what we have now is a class and a buffer, and we'd like to do things with the buffer, things that people like to do with strings. Now, I have used MFC before, and I know that their string class has functions with names like this: TrimLeft, TrimRight, with capitalized words. Remove, I don't know if they have that, but capitalized anyway. To trim something means to remove all matches in the string of characters matching a particular character set. That character set is specified here, and it defaults to what is called white space. And white space is space tab and carriage returns and line feeds, I decided, as opposed to blank space, which doesn't include carriage returns and line feeds. So in general, if you don't specify anything, this trim right or left of a string removes those types of characters. So let's see it in action. First, here's a string. As I mentioned before, there is a function like this, similar to exactly the same name as the one in the STL version, which returns a pointer to characters. The C string, null terminated string, taken from this class. This class, however, also has a cast member somewhere in here that calls that function here. So, in fact, I don't need to put that in this case. This will invoke the cast, because this function takes this as an argument, this type as an argument. Cast will get invoked, and so put as is fine. A lot of people disagree with having a cast like that. I find that it's handy, and you get tired of typing C_stir everywhere. So I keep it. It's my preference. You could, if you wanted to, remove it. Take the code and remove that cast. And then you have to type C_stir everywhere. Okay, now I'm going to put some white space here on the left and on the right. Now, unfortunately, we can't see this white space when we print it out, but we could put something like bars. Let's say same thing. If I put bars around my string, then I should see more spaces here. I'll be able to see where the spaces are in the printout. Okay. Now, according to the function, if I say stir.TrimLeft, that's all I gotta do, because the default includes spaces. We should see that this part will get removed. And it did. Similarly, if I remove the right characters, or trim, sorry, it trims off those spaces on the right. And that should be true even if I have tabs and carriage returns. Now it's going to look a little bit weird, because it's going to be on the next line. Right? But this got trimmed off. It went carriage return, and then a bunch of spaces, and hello world, and all this got trimmed off because of the characters that I chose. I could TrimRight only carriage returns, let's say. No, line feeds, let's say. Suppose I specify I only want to trim line feeds. Now, what do you suppose I'm going to get? TrimRight. Well, the answer should be you should get what we already have. Now, no effect, and the reason there's no effect is because it's a trim takes away things on the end, right? If I'd include the spaces in line feeds, then it will get rid of everything from here onwards. I'll still have the tab. That's a tab. Definitely this was not included. But if this was a line feed, then it should get rid of all of that. Okay. Now that's pretty easy to understand. Putting them both together, this just combines the two operations. And if I do it with no parameters, that's going to trim the right and the left. of those characters. Now, trim is quite useful when you're reading lines in from a file, let's say, and you want to get rid of like leading spaces, something like that, to make a nice printout. Okay. Now, how does it work? There's really nothing to it. Empty, don't do anything. Now you need a function of this type. This is a set of characters that I want to trim, in this case on the right. What I need to find is the last occurrence of a character which is not within this set. And that's what this does. And it's using a runtime library function. Or did I invent this? I probably invented this myself. Yeah, I did. There is no such runtime library function, but there is one for the forwards direction. So I made it look like the forwards direction one. Here's the forwards direction one. R for reverse. Same lettering and syntax. All this does is find the last occurrence, which is not in this set, in this string. You can look this one up in the help file, and just the other one is in reverse. Now let's see. This says if first. Now, so if the first character, which was not in the trim set, was equal to length, like the end, then that means that all of the characters in my string are within this set, and so I should just clear everything out. Otherwise, I want a substring of my string. Mid here is a substring extractor, which works like the MFC version of mid, or the batch version of mid. It takes one or two numbers. The first number is where to start from, and the second number, if it's there, is where to end. Is the length to copy. If you don't specify anything, it just means go to the end. So that means I would like the first this many sorry. If there's one number specified, it takes characters from 0 up to that number. The first so many characters. Let's look here. Nothing. No, I'm wrong. Okay. Oh, and on TrimLeft, that's what I'm. Okay, on TrimRight, I want to go from 0 up to that number that we found, the last non-trim thing, right? Simple enough to understand, as long as you can figure out how this mid works. For the left, it's just the same idea, but going from the left, which is actually easier. Find the first character which is not in the set. If that's equal to the length, then all the characters are in the set, clear it out. Otherwise, I would like all characters starting from the number found to the end. That's TrimLeft and that's TrimRight, and they both depend on this mid. So how does mid work? Well, there are two versions. If there's a single number, all you do is this means I want all characters from this position to the end. If this specified number is actually greater beyond the end, therefore I'm going to return an empty string. Otherwise, I take my starting position, I had this many characters, and return that position. Now this thing returns a string, a brand new string, by the way. That's why this is declared as const. I didn't modify this object. So this return here is returning something of type string, long pointer to constant characters, right? But that has a conversion to string, so I don't need to explicitly cast this. Just returning that value is fine, and a new string will be constructed from this pointer. As for if there are two numbers given, it's positioned to start at number of characters requested. So if my length is 0 or the count is 0, then return nothing. Didn't ask for anything. But either we don't have anything to give, either we don't have anything to give, or we were asked to give nothing, in which case we give nothing. If the count is negative, now negative in this case, like MFC, means go to the end. Or if first plus count is beyond the end, so both of those cases would say go to the end, we use this function that we've already defined. Otherwise, we're in a situation where we have a first and we have a count, and it's some substring within the string not going to the end. Okay, so now we start at the position given, and I'm defining here a TsString for the return value. Remember, this is const, so we're not modifying this string, we're creating a new substring built from our string, and this is going to be the return value. Now I know immediately what the size of this new string is going to be. It's going to have a length of n count. So we need to resize its buffer to count plus 1 with no terminator, and we can immediately say that its length is going to be equal to that. Now we just do a regular old string copy into the return values string of this many, the second argument for this function is the size of the buffer being copied to, which is count plus 1. This is the source, and here I say truncate, although it's not really necessary. Make sure it's null terminated. And here an assertion, again, that the length that I just specified by a value should be equal to the length calculated using SetLength. and return that. Okay, now that covers a lot of things all at once, believe it or not, because, let's see, okay, this is easy enough, right? And that required us to understand mid. Mid is for extracting substring. Now, there are a whole host of functions, all based on this mid. If you know mid, you can do, if you know how this works, you can do all sorts of other things that involve substring. For instance, I have a function here which returns me a string, not modifying the string, but returns me a string which is the right so many strings. And that's just a matter of applying mid in the, with the right parameter. For instance, in our program. An example. Suppose I want the right 3 characters of this string. So that should print out AGL. And all that is just applying mid. Right, sorry, that's right, that would be RLD. Okay? So we take length minus count, and this many characters. And we don't want any negatives. So this here takes care of the case where we made an error in judgment. Let's just see it work for a second. RLD, right? Now the error case would be if I said I want the right 300. In that case, there aren't 300, so it should just give me hello world. And you can see that I'm taking care of it. But I take length minus count, and if that's negative, then the maximum of 0 and a negative number is 0, and then count. Right. So the max mid count. Now count's a great big number, and we've already mid handles great big number case. Left works the same way. So you get all these functions for free with mid. Here again, cutting things away. Now these ones modify the string. If I want to cut so many characters from the head, I can assign to this object some value returned from mid. So, you can work those out yourself. And so left, right. Now, and the trim, removing and replacing, and all those sort of search replace things I'll cover in a later video. Let me just show you some of the very simple ones. Make reverse uses a built runtime library thing that reverses strings, and I just call it directly, and it returns it. This one returns a reference. All these return reference to object. quote, put quotations around the string. You can imagine how that works. Capitalize makes sure that the first letter is capital and the rest are lowercase. Let's see that working. Again, using mid, I take the first letter from 0, one character from 0, and call in the uppercase of that. And then I take everything else and put that into lowercase. And how does toupper and tolower work? These use runtime library functions. And they all return references. Now you might want to have the lower or uppercase version of a string without modifying it. And for those sorts of things, I have these, instead of reversed. So this is like a past participle, and all that does is make a copy of the string and then reverse that. If I wanted AsUpperCase, make a copy uppercase. You see what I'm saying? I can capitalize, or I can have a capitalized version of a string that doesn't modify it, quoted instead of quote. You see? And all those sorts of things are based on mid. Okay. Now this finding stuff for later. So that's basic formatting and casing, capitalizing, quotation, and all these things use mid and some simple runtime library functions, and you've got the ability to do quite a few things. Because especially when these things return references, you compound them, you know. I can quote that left 3 characters that I extracted. See? Unfortunately, I've made a mess of stir. Oh no, that stir is fine. Them is fine. Oh, because left 3 doesn't return a reference. That returns that. That doesn't modify the string, and this operates on the copy. So that's okay. If I did this backwards, that would be bad, or different. First I will quote my string and actually modify stir, and then take 3 characters. The result like that, and my string would get messed up. But that would not happen if this was like that. I'll print out the same thing, but my string won't get modified because quoted doesn't modify the string. Okay, that's enough for that. See.